Good morning, friends. Welcome to another video. Today I am covering Jidoka. It is a Japanese concept and it is one of the foundational pillar of Toyota production system apart from just in time. I will cover just in time in my another video. Today I am just covering the Jidoka. The word is often translated as automation with a human touch or automation or intelligent automation. Unlike ordinary automation, which simply keeps machine running, Jidoka means machines and people should immediately detect abnormal conditions, stop the process, and prevent defects from moving to the next stage. In simpler words, do not produce bad quality products. If something goes wrong, stop immediately, identify the root cause, fix it, and then restart. So this is the very basic definition of Jidoka. How Jidoka and when it is originated. So Jidoka originated in the early 1900s with Sakichi Toyoda, the founder of the Toyota Group. He invented an automatic weaving loom. Before his invention, imagine one worker supervising 20 weaving machines. If one thread broke, then the loom continued running. It produced meters of defective cloth, hundreds of meters turned to waste because there is no value of waste. So if there is a thread which is broke, then there is no point of selling or producing the defective part. So this was happening prior the introduction of Jidoka. Sakichi Toyoda's idea, he designed the loom so that it detected a broken thread. The machine stopped automatically. An alarm alerted the worker. What was the result? Only a few centimeters of cloth were defective. Instead of hundreds of meters of cloth was defective, after the Sakiji Toyoda's idea, only a few centimeters of cloth was defective or produced as a waste. Waste reduced dramatically. One worker could safely supervise many machines. So Jidoka is the capability of equipment or operators to automatically detect abnormalities, stop production immediately, notify responsible people, and prevent defective products from progressing further. The philosophy is quality should be built into the process, not inspected afterward. Generally, what happen is quality team go for the inspection, and if there is a abnormal behavior or there are defective parts, they can look at it and they can suggest the improvement at the time of inspection. But the concept of Jidoka is quality should be built into the process. There should not be defective products. Quality team will not do figure out these defective products at the time of inspection. Instead, the defective product should not be produced at the time of production. There are four steps of Jidoka. First one is detect the abnormality. Something unusual happens. Let's say a missing bolt, there is a broken thread, a wrong temperature, a machine is overloaded, or wrong component. So this is the unusual behavior. Step 2 is stop the process. Instead of continuing with the unusual behavior, machine stops automatically. Conveyor stops, robot pauses the operation, operator presses the stop button. Stopping prevents additional defects. Let's say there are two or three defective products produced at the time of production, but worker or the machine figure out that there are defective products, so machine stops automatically and a message is sent to the concerned person to look after it. Step 3 is fix the immediate problem. The issue is corrected. Example, replace broken tool, tighten loose bolt, refill material, or replace faulty sensor. I'm just giving example here. It can be anything according to the abnormality which is figured out in the step 1. Step 4 is eliminate the root cause. The permanent cause is investigated. Common tools include 5 whys, fishbone diagram, Kaizen, standard operating procedures, SOPs. So these are the tools which help in eliminating the root cause. I will cover this in a separate video. So just remember the name 5 whys, fishbone diagram or Ishikawa diagram, Kaizen or continuous improvement, SOP. The objective is to ensure the problem does not recur. Let's understand this with a real life example. So I took here an example of Coca-Cola bottling plant. Imagine a Coca-Cola factory producing 60,000 bottles per hour. That means 1,000 bottles every minute, around 17 bottles every second. Since production is so fast, humans cannot inspect every bottle manually. Instead, the factory relies on Jidoka through sensors, cameras, PLCs, programmable logic controllers, and automated inspection systems. Step 1 is empty bottle inspection. Before filling, empty bottles arrive on a conveyor belt. They are checked for cracks, dirt or dust, broken necks, wrong bottle type, foreign objects inside. So this is the first step. Without Jidoka, a cracked bottle enters the filling machine. After filling with carbonated drink, the bottle bursts because of internal pressure. Consequences are beverage spills, nearby bottles get contaminated, the production line must be cleaned to proceed further. Production stops unexpectedly. But after the production of Jidoka, a vision camera detects the crack. The system automatically rejects the bottle using an air jet or mechanical arm, prevents it from entering the filling machine, continues production with good bottles. No waste of beverage occurs. So, Jidoka helps in prevention of wrong bottle entering the filling area. Step 2 is fill level inspection. Each bottle is filled with Coca-Cola. Suppose the target is 500 ml, but there can be possibility of, let's say, a bottle is filled 450 ml, which is less than 500 ml and considered as underfilled, or 550 ml, which is considered as overfilled. So underfilled bottle, customer receives less product, the company loses customer trust. Because if you send a less quantity, the customer become unhappy and there is a chance that customer will not buy the product again, and Coca-Cola failed to retain the customer for future buying. Overfilled bottle, beverage spills during capping, sticky conveyor belts, increased cleaning, and product wastage. So it is the loss of Coca-Cola in case the bottle is overfilled. How Jidoka works? Laser sensors or camera measure the liquid level. If the bottle is not within the acceptable range, it is rejected automatically. The filling valve is inspected. If many consecutive bottles are defective, the machine stops and alert the maintenance department. Instead of producing thousands of defective bottles, only a few are affected. Step 3 is cap inspection. This is one of the best example of Jidoka. After filling, each bottle receives a cap. Let's imagine one capping head becomes loose. Every 10th bottle leaves the machine without a cap. Without Jidoka, what happened? The conveyor continues. Problem arises are beverage leaks, carbon dioxide escapes, product becomes flat, dust enters the bottle, customers receive unusable products. Hundreds of bottles may be affected before someone notices the fault. But after Jidoka, high speed camera inspect every bottle. The system checks, is a cap present? Is it centered? Is it fully tightened? Is the cap the correct color and type? If the bottle has no cap, a reject mechanism removes it immediately. If several bottles fail in succession, that is one after another, the line stops automatically, which is not happened when Jidoka was not in place. An alarm and then notifies the operator. Maintenance repairs the capping machine. Production resumes only after verification. So this is the advantage of Jidoka. Step 4 is label inspection. Every bottle must have correct label, straight label, proper barcode, correct expiry date, and correct batch number. Suppose labels are being applied upside down. Without Jidoka, 10,000 bottles are produced before someone notices. The company must recall products, remove labels, relabel bottle, spend additional labor and time. But with Jidoka, vision systems compare each bottle with the correct reference image. There is an reference image and the vision camera compare each bottle with that particular image. If labels are crooked, missing, upside down, incorrect, the bottle is rejected automatically and repeated failures trigger an investigation of the labeling machine. A message is sent to the maintenance team. The people will look at it and whatever the root cause is, they fix it. Step 5 is packaging inspection. After labeling, bottles are packed into cartons or shrink wrapped trays. Suppose each carton should contain 24 bottles. Problem is only 23 bottles enter one carton. Without Jidoka, what happened is the customer receives an incomplete package. Instead of 24 bottles, a customer receive only 23 bottles. So this is again the against the customer satisfaction. The company lose customer and it is quite difficult to retain the customer. But with Jidoka, the weight sensors or counting systems verify the number of bottles. If the carton is underweight, it is diverted from the line. The packing machine is checked. Production continues only after correcting the issue. Step 6 is root cause analysis RCA. Imagine the plant experiences repeated missing cap defects. Instead of only replacing defective bottles, the maintenance team investigates the root cause using the 5 why, the tools which I mentioned earlier, 5 whys, Kaizen, SOP. So this is the 5 why. 5 why is basically you are asking 5 questions. Why this is happening, why this happened, like that. First one is why was the bottle uncapped? The problem can be the cap was not applied. Why was not the cap applied? The capping lad had missed the bottle. Why did it miss? The capping head was misaligned. Why was it misaligned? A mounting bolt became loose due to vibration. Why did the bolt become loose? Preventive maintenance did not include periodic torque checks. So by performing 5 why, we can find out the root cause behind the problem. Permanent countermeasure. First is update the maintenance checklist, add regular torque inspections, install a sensor to detect capping head misalignment earlier. This is the fixed root cause part of Jidoka. So this is the root cause and this is how the root cause is fixed. So complete Jidoka flow in a Coca-Cola plant is empty bottles, then bottle inspection, bottle filling, fill level inspection, cap installation, inspection, labeling, label inspection, packaging, weight and counter check, and it moved to the warehouse. After the warehouse, it moved to the customer. So this is the basic flow in a Coca-Cola plant. I hope you understand what is Jidoka, how it is originated, and what companies or the organization facing prior introduction to Jidoka and how Jidoka helped in preventing the defects. If you want more such videos, please subscribe my channel. Thank you.